Something strange is happening to Europe, and almost nobody is talking about the real reason why. Right now, as you watch this, Europe is heating up faster than any other continent on Earth. Not Africa, not Asia, not even the deserts of the Middle East. Europe, a continent full of rain, gray skies, and mild summers, is now warming at nearly double the global average. And the reason isn't just carbon dioxide. It isn't just cars or factories or the things you've already heard 1,000 times. There is a hidden mechanism driving this, something almost nobody expected, something that sounds less like climate science and more like a plot twist. And once you understand it, you will never look at a clear blue European sky the same way again. Let's start with the numbers, because they are almost hard to believe. Since the pre-industrial era, the planet as a whole has warmed by about 4 degrees Celsius. That's the number you usually hear in the news, the number tied to international climate targets, the number politicians argue about at summits. But Europe hasn't warmed by 4 degrees. Europe has warmed by roughly 2. 4 degrees, almost double the global figure. If you live in Madrid, Berlin, Rome, or London, the ground beneath your feet has heated up nearly twice as fast as the rest of the planet. And it isn't slowing down. In just the last few years, Britain, France, Italy, and Spain have all issued red heat alerts during what should be mild spring and early summer weeks. Records that used to fall once a decade are now falling every single year. So the question isn't really whether Europe is heating up. It clearly is. The real question is why on earth is it happening so much faster here than almost anywhere else? The first answer scientists give you is the simple one, the one that makes sense on the surface. Europe is mostly land, and land heats up faster than oceans. Water can absorb enormous amounts of heat and release it slowly through evaporation, acting like a natural buffer. Land has no such buffer. It heats quickly under the sun and it cools quickly at night. But when you add a steady stream of extra greenhouse gases into the mix, that quick heating becomes a serious problem. Compare that to a continent like Australia, which is surrounded by vast stretches of ocean acting like a thermal sponge, and you start to see why a landlocked, densely built-up Europe reacts so violently to a warming atmosphere. But land alone doesn't explain a doubling of the warming rate. If it did, every large landmass on Earth would be racing ahead in the same way, and they're not. There is something else going on, something regional, something almost personal to Europe's geography. That something is the Arctic. Europe, more than any other populated continent, is physically wired into the Arctic circulation system. Northern Scandinavia, Svalbard, Iceland, all of it sits right at the doorstep of the fastest warming region on the entire planet. And when we say fastest warming, we are not exaggerating for effect. The Arctic has warmed by more than 3 degrees Celsius since pre-industrial times, more than double even Europe's already elevated number, and nearly 2.5 times the global average. That's not a typo. The top of our planet is heating up at a pace that should genuinely alarm anyone paying attention. And because the Arctic sits right next to Europe, whatever happens up there doesn't stay up there. It bleeds south. Here's the mechanism, and it's honestly a bit terrifying once you picture it. Sea ice used to blanket huge portions of the Arctic Ocean, acting like a giant mirror, reflecting sunlight straight back into space before it could ever heat the water below. But as the planet warms, that ice is melting away at a staggering rate, exposing dark, open ocean underneath. Dark surfaces don't reflect sunlight, they absorb it. So instead of bouncing solar energy back into space, the newly exposed ocean soaks up the heat like a sponge left in direct sun. That absorbed heat warms the water even further, which melts even more ice, which exposes even more dark ocean, which absorbs even more heat. It's a feedback loop with no natural brake pedal, spinning faster every single year. And Europe, sitting right beside this overheating engine, gets dragged along for the ride through shifting wind patterns and atmospheric circulation that increasingly funnel warm, unstable air straight across the continent. But here's where the story takes a turn nobody saw coming, a twist that even trained meteorologists describe as almost paradoxical. Just west of the British Isles and south of Iceland, in the middle of the North Atlantic, there is a patch of ocean that is doing the exact opposite of everywhere else on the planet. It's cooling down. Scientists call it the cold blob, and it is, quite literally, the only major region on Earth where surface temperatures have been dropping instead of rising. On paper, that should sound like good news, a little pocket of relief in an overheating world. It is not good news. It might actually be one of the most dangerous signals in the entire global climate system, and it's happening right on Europe's front doorstep. To understand why a cooling patch of ocean can make the land next to it hotter, you need to understand the engine that keeps Europe's climate mild in the first place, a system called the Atlantic Meridional Overturning Circulation. Think of it as a massive underwater conveyor belt. Warm, salty water travels north from the tropics along the surface of the Atlantic, eventually reaching the seas near Britain and Scandinavia. There, it releases its stored heat into the atmosphere, which is precisely why places like the UK and Norway have historically enjoyed climates far milder than their northern latitude would suggest. After releasing that heat, the water cools, becomes denser, and sinks deep into the ocean, flowing back south along the bottom to start the cycle all over again. This conveyor belt has been running for thousands of years, quietly regulating European weather in the background. Now that engine is stalling. Glaciers across Greenland are melting at an accelerating pace, and combined with heavier rainfall linked to the warming atmosphere, they are pumping enormous volumes of fresh cold water into the North Atlantic. Fresh water is lighter than salt water, and lighter water doesn't want to sink. So the conveyor belt that has quietly regulated European climate for millennia is losing momentum, slowing down like an engine starved of fuel. That slowdown is what creates the cold blob, a stubborn pool of unusually cool water sitting right where warm currents used to surface and release their heat. For years, scientists treated a full collapse of this system as a distant, almost theoretical risk. It no longer looks quite so distant, and this is the part that should genuinely unsettle you. A cooler patch of ocean water right next to a warming continent doesn't create balance, it creates chaos. That sharp temperature contrast between the unusually cold Atlantic water and the increasingly hot European landmass distorts atmospheric pressure patterns overhead. It has been linked to the strengthening and increased persistence of high-pressure domes parked directly over Western Europe, the exact kind of stagnant, sun-baked weather systems responsible for the brutal, record-breaking heat waves that have battered Britain, France, and Spain in recent years. In other words, the very mechanism that once kept Europe mild is now malfunctioning in a way that is making things hotter and more extreme, not cooler. A cooling ocean, quietly making a warming continent even worse. But even that isn't the strangest part of this story. There's one more factor, and it might be the most counterintuitive of them all, because it means one of the great public health victories of the last 50 years has an unexpected dark side. Since the 1980s, European governments have worked hard, and largely successfully, to clean up air pollution. Stricter regulations slashed the aerosol particles pumped into the sky by factories, vehicles, and power plants, particles that used to hang in the atmosphere and cause serious respiratory illness. Fewer aerosols means healthier lungs, cleaner cities, and clearer skies. Genuinely good news and a policy success story that saved countless lives. Except those same aerosol particles were doing something else, something scientists didn't fully appreciate until they started disappearing. They were also reflecting sunlight back into space and helping clouds stay brighter and more reflective. In effect, decades of air pollution had been quietly acting like a thin, dirty sunshade over the continent, unintentionally masking a portion of the warming caused by greenhouse gases. As that pollution was cleaned away, the sunshade came down with it. More solar radiation now reaches the surface. Clouds are thinner and less reflective. And all that extra sunlight that used to get bounced back into space is now hitting European soil directly, adding yet another layer of acceleration on top of an already overheating system. This is the twist nobody wants to hear out loud. The effort to protect European lungs quietly opened a window that let in more heat. Not a reason to regret cleaning the air. That decision has saved an enormous number of lives. But a sobering reminder that our planet's climate system is stitched together in ways that are far more tangled and interconnected than most people realize. Put all of these pieces together and you start to understand why Europe's warming isn't a simple story with one villain. It is land heating faster than ocean. It is a continent tethered to a rapidly melting Arctic. It is a stalling ocean current creating a cold anomaly that somehow fuels hotter, drier, more stagnant weather on land. And it is decades of genuinely well-intentioned pollution cleanup, accidentally removing a layer of accidental protection. 4 separate mechanisms, each one independently pushing temperatures higher, all converging on the same unlucky continent at the same time. And the warming isn't spread evenly across Europe either, which makes the picture even more unsettling. Eastern and southeastern Europe, along with mountainous regions like the Alps, have been warming at somewhere between half a degree and a full degree Celsius per decade over the last 30 years. That is an aggressive pace by any historical standard. Western and southwestern Europe, along with the subarctic reaches of Finland, Norway, and Sweden, have been warming at a slightly gentler but still alarming pace. And then there's Svalbard, the remote Norwegian archipelago sitting deep in the Arctic, home to polar bears, and some of the most pristine wilderness left on the planet. Svalbard is warming at somewhere between 1.5 and 2 full degrees Celsius per decade. Read that again, not per century. Per decade. If that trajectory continues even for a few more decades, we are looking at a transformation of the Arctic landscape that is almost impossible to fully picture, and Europe sits right downstream of all of it. The consequences of this are not abstract or theoretical. They are already showing up in people's daily lives across the continent. Heat-stressed days, the days hot enough to pose a genuine danger to human health, have been climbing year after year, with recent summers ranking among the worst ever recorded. Hospitals across southern Europe have reported spikes in heat-related illness during recent heat waves. Wildfires have torn through parts of southern France, Greece, and the Iberian Peninsula with an intensity and frequency that firefighting services are increasingly struggling to keep pace with. Farmers across the continent are contending with shifting growing seasons, unpredictable rainfall, and crops stressed by heat spikes that arrive earlier in the year than historical records would ever have suggested possible. And infrastructure built decades ago for a milder climate, from rail lines that buckle in extreme heat to power grids strained by relentless air conditioning demand, is being tested in ways engineers never designed for. There's also a quieter, slower-moving threat tied directly back to that stalling ocean conveyor belt, and it's one worth sitting with for a moment. For years, a full shutdown of the Atlantic meridional overturning circulation was treated by most scientists as an extreme, low-probability scenario, something worth mentioning in footnotes rather than headlines. That confidence has been eroding. Nobody is claiming collapse is imminent or certain, and it's important to be honest about that uncertainty rather than sensationalize it. But the direction of travel, a weakening current, a growing cold blob and increasing freshwater input from melting ice, is consistent, and consistency is exactly what should make anyone pay closer attention. If that current were to weaken dramatically or stop altogether, the consequences for European climate wouldn't just be an intensification of what we're already seeing, they would represent an entirely different kind of disruption, potentially bringing far colder winters to parts of northwestern Europe, even as the rest of the planet continues warming. A genuinely bizarre outcome, cold snaps born directly out of global heating, and one more reason this cold Atlantic patch deserves so much more attention than it currently receives. So, where does that leave us? It leaves us with a continent caught in a kind of climate pincer movement, pushed from the north by a rapidly melting Arctic, destabilized from the west by a faltering ocean current, creating an anomalous cold patch that somehow fuels hotter, drier land conditions, and exposed from above by the loss of a pollution layer that had been unintentionally shading it for decades. None of these factors are hypothetical or speculative. They are actively measured, tracked, and documented right now by climate monitoring services across Europe. And none of them are slowing down. What makes this genuinely difficult to sit with is that some of the very policies that made Europe a healthier, cleaner place to live are tangled up in the very mechanism accelerating its warming. That is not an argument against clean air. It is instead a stark reminder of just how deeply interconnected our planet's systems really are, how an action taken with good intentions in one domain can ripple outward and create unintended consequences in another. Europe's accelerated warming isn't the result of one mistake or one villain you can point a finger at. It's the result of an intricate, interconnected system reacting to multiple pressures at once, some obvious, some genuinely surprising, some almost impossible, to have predicted decades ago when the relevant policies were first written. The heat waves currently breaking records across Britain, France, Spain, and Italy are not isolated weather events that will simply fade into memory once summer ends. They are symptoms of a deeper structural shift happening beneath the surface of an entire continent, a shift being pushed forward simultaneously by melting Arctic ice, a stalling ocean current, and cleaner skies that let in more sun than anyone anticipated. Europe is not just getting warmer. It is getting warmer for reasons that are stranger, more tangled, and more interconnected than almost anyone expected. And that, more than any single heat wave or broken record, is the part of this story that deserves your full attention. If this opened your eyes to something you didn't know before, make sure you're subscribed because there is a lot more of this coming. Hit like, drop a comment telling me which part surprised you most, and I'll see you in the next one.